become masters of all knowledge. So we divided it into physics, chemistry, biology, mathematics, and then subdivided it, chemical physics, biochemical physics, mathematical biochemical physics, and then we divided it so much that we all became narrow experts without knowing much about any other field. And that is the world that we have created today, where we know something apparently very deep on a topic so narrow that it is irrelevant to most people. This has been the biggest cause for most of the disasters that we have. The reason is that we tend to because of our narrow views, we tend to optimize only certain things, keeping the others unknown, and we don't even care about them. But most of the problems that arise to us are multi-objective, multi-dimensional, multidisciplinary. And that the first person, the first entity which has suffered and continues to suffer is our planet. Nobody bothers about the planet. Everybody bothers about optimizing profit or something else. The first integrator of knowledge, of this divided knowledge, was computation. Computation is a general purpose modeling scheme which allows us to model any discipline. And because of this, you started having computation as a spouse of all disciplines. Computational physics, computational chemistry, computational biology, computational sociology, computational economics, computational digital humanities. So computation became the spouse of every discipline. Every discipline used computation to understand that discipline better. But computation almost never merged with the discipline. Next integrator, though computation was there in different disciplines, it did not integrate across disciplines. Artificial intelligence, along with the power of electronics, became a true integrator. Artificial intelligence started answering, started posing this problem. The problem that it posed is that, can I have a general purpose method to solve any problem? I don't want to have a method to solve a physics problem, a chemistry problem, a biology problem, economics problem. I want to solve any problem. I don't want to label it by a field. And therefore, in order to be able to solve any problem, whether it's a path planning problem, whether it's a chess playing problem, a robot assembly problem, a chip layout problem, a timetable scheduling problem, or a symbolic integration problem, or a protein folding problem, or whatever, or understanding some physics equations, I want to do it the way we did it in school. A question paper would come, and it doesn't matter whether it's which subject it is. It's just a problem. And I want to have a solution to that problem. So in order to solve that, AI came up with this triangle, this hexagon that I've drawn, six-sided figure, is the star. Every philosophy, you know, Star of David. Every philosopher creates a philosophy star like this and some symbol inside. So I have created this. The upper triangle is the core of AI. It consists of three legs. The first is, if I want to solve any problem, then I need to be able to represent any problem. I don't want to represent a physics problem separately, a chemistry problem separately, a biology problem separately, an economics problem separately. I want to just represent anything. So I need to have a generic representation, or it's also called a model. The second is, if I have a representation scheme, I represent the problem statement and the knowledge about the problem in that same representation. And then I want to have a solver or a mechanism that tries to solve that problem. So I want to have a generic mechanism. The third and the most important part of AI, which was not there in computation, is learning. Learning says that every time I solve a problem, next time I go to solve another version of the problem, I solve it differently because I have learned from my past attempts to solve the problem. So I don't write a sorting algorithm which runs every time the same way it does. If it sorts 30 times, the 31st time it will do something based on what it has learned. And this upper triangle is representation, reasoning, and learning. And these three reinforce each other. Learning improves representation and reasoning. Reasoning improves representation and learning. And representation, the better the representation, the better the reasoning and the learning. So this is the regenerative cycle. Today's AI and AI people are very dangerous. They will use a discipline, they will borrow from the discipline, they will make improvements in the discipline, change the name, and say it is me. The first is all of algorithmic representation. The way we represent anything algorithmically, whether it's a physics problem, chemistry problem, we have data structures, we have algorithms. So AI people called it symbolic AI. It is basically algorithmic AI, which is a step-by-step method of AI. So if I want to go from here to the airport, then there is a step-by-step method. So symbolic AI or algorithmic AI or crisp AI has got its representation, reasoning methods, and learning methods. But then we all found that a large number of problems, from election prediction to monsoon prediction, etc., depend on statistical information. You really cannot find an exact solution. So you find a statistical solution. And therefore, AI people used all of statistics, made more and more improvements on it, changed the name, so it had representation in statistical representation, statistical algorithms, and statistical learning, and changed the name. Guess what is it called today? The AI people, as I told you, they change names of everything and own it. It's called data science, basically statistics. But the third leg was most interesting. The third leg is the following. If I give you a picture of Professor Shomendra, you will look at the picture and I ask you, who is it? You will say Shomendra. But if I ask you to, so how much time it took for you to find out? If I ask you to go, how will you find the path from here to the airport? You will think, and then you will come up with a path, step by step. But this answer is instantaneous. You have said that this is Showman. But then if I ask you, prove to me it is Showman. Wherever, if I told you, prove to me that this path is correct, you will show me the path on the map. But if I ask you, prove to me it is Showman, you will not be able to. You will have hundreds of sentences, I is like this, here is like this, etc., etc. But nobody, you can write 20,000 pages, but you will not convince anybody. It is not a proof. Finally, you will say it matches with other pictures of Showman. fact, if I give you a picture of Showman as a 8-year-old guy, I assure you that 80% of you will recognize it as Showman. And instantaneous, and yet cannot prove it. This is cognition. This is a completely different form of representation, reasoning, and learning. And human beings struggled with it and eventually took a mathematical cartoon of the human brain. They had a mathematical model, a very simplified model of a node which is a nonlinear structure and connected up in various ways, which I shall show, and called it a neural network. So these three, this lower triangle, are the three current methods, and all of them are mishmashed into this representation, reasoning, and learning together. And now you give any problem in this domain, it will use a combination of these three methods and solve it. The fourth method that is coming up, which will again dramatically change the way we have got this connectionist model, is quantum. Once you have quantum representation, quantum solving, and quantum learning integrated into this, then obviously there's going to be much more. So at the heart of all this, at the heart of all this are 5 or 6 base methods. All of AI is like researchers like all of you. Every research, every problem solving is basically a search in, a, in an intricate space of problem solutions. So search is the foundation of all of AI. Whether any of these three methods, looking for an easy way to find a solution is. The second is logic. I know wherever Mary goes, so does the lamb. Mary goes to school, so the lamb goes to school. It's logic. No contractors are dependable. Some engineers are contractors. Therefore, some engineers are not dependable. So the second is this foundation of logic, which is a 3,000-year-old discipline. The next is language. Language itself, other than grammar, language is much, much beyond grammar. We say so many things in same thing in 5 different ways, and people still understand. And therefore, at the heart of AI is language. And we shall come to more of it. Then a large number of our problems are defined by data. You don't define the problem. You say, I have got these experimental results. Can you tell me what they mean? Is there an underlying, if I give you hundreds of objects of motion and I will show, tell you something very interesting, is that just giving motion data, AI today has tried to find patterns and has found in its own way rediscovered Newton's laws of motion. So how do you look at data and discover patterns, theories, integrate methods? And as I said, this single concept of a nonlinear node, which connected in an acyclic graph, has been proved to be able to represent any function from R to R. Any function. If you have sufficient number of such neurons, you can now model any function. The second is this one. When everybody is connected to everybody, it creates associative memory. It creates memory of various kinds. And this name will sound interesting to you because can anybody tell me what happened? What about this person? He won the Nobel Prize last to last. Hupfield won the Nobel Prize. Among his contributions is this network. So they are able to show that these networks connected in different ways can model memory, computation, music, dance, and everything else. So, memory means you are able to model patterns, you are able to model history, you are able to model time series. Then you represent knowledge. I don't want to go into it. and, and in all of this, electronics gets embedded, which means that these sensors, actuators, everything is collecting data all the time. So, what has been the conquests of AI? Three things have made AI really what it is today. Not much of the science, obviously, the science, the theory, the algorithms, the methodologies, the modeling is important. But the first thing that has happened is compute has almost become free. The amount of compute that you can do in a mobile phone, which is available with each one of us, is unimaginable. We all know that our biggest dustbins are our hard disks. We don't even know what information we have there. Third is communication. Today, everybody is communicating to everybody with WhatsApp, phone, call, etc., etc. So bandwidth has become free. So today, all the computers in the world can be connected to do a single computation if you want. And this combination has enabled us to cross barriers which we thought we would never be able to. So the power of computation, the power of communication, and the power of memory storage has really become the technology driver, along with that star that I showed you, to make AI what it is today. Can anybody tell me what this is? Who's this guy? And nobody? Huh? This is Gary Kasparov when the first time the world champion lost to a computer. And today, the world, if you list the computers that play and the human beings that play, the best human beings will be 100, more than 100 below in the ranking. The famous Turing test was if you are interacting with somebody on the other side and you cannot make out whether that person is a computer or a human being, then you have done the intelligence test. But today, all of us who use Chat GPT or anything else, we are scared that the other side is more intelligent than us. Forget about it. We can make out that that is beyond human intelligence. So today, when a Boeing aircraft is flying, it is simulated, its aircraft is simulated real time. And if there is anything wrong, they try to rectify it on the fly. And if they can't, then by the time it lands, it has got a replacement or something is ready. So this concept of digital twin, and all of us are afraid of self-driving cars. 95% of the time you fly in the airplane, it's all autopilot. It's all on autopilot. But that is still history. Let us come to today's model. Today's model is the famous large language model. Now, what is the large language model? As I said, the large language model enables us, today's AI enables us to combine disciplines and write it down and combine disciplines in such a way that It is unimaginable that we will be able to understand that this is the way disciplines can be combined. And how many of you use ChatGPT all the time? I guess everybody. So just open up your ChatGPT and write this statement down. I was doing it while I was coming in the car. Just try it. All of you just try it. You write down, explain to me the theory of relativity using the example of cricket. And or you say, write down a poem to explain the theory of relativity using the example of cricket. Do it once. Did anybody get the answer? Did you get the answer? Nobody? Did anybody get it? Some people are smiling. You got it? Who got it? Please raise your hand. Is it, does it make some sense? Interesting? And you will see all of you got a very interesting way of it being represented. And I can show you what I got. It talks about when the ball is moving near the speed of light, what happens? And if you, the player who hits it with the speed of light, sees it move rapidly, whereas the audience who is watching it in some other way, see it in some other way, and things like that. Has everybody, has some of you got it? Please raise your hand, I want to see. Interesting? And everybody has got a different one. You check. That is the most, nobody has got the same thing. Have you got the same thing? Different or same? Different. So now you see the power. This is a simple example. So the question is, how is it achieved? How is it that I am able to combine knowledge of all disciplines into one system and present it to you in any way I want? So there are two components. A very simplified way of explaining them is that it contains two components. The first component is called the encoder or the predictor. What does it do? It takes any input, creates a compact representation, the representation I talked about, and starts analyzing the properties of that input. Sir, don't continue with that. You will go mad. You will go mad. After some time, you will try to say, you will try to do very, very funny things, and everything you will be able to do. So, for example, you give this picture and you try to generate its properties. This is a male. This person is walking. This person is of middle age, 60, something like that. Or you give a video, or you give a voice, and you say that this is a female voice, the accent is British, the language is English, and so on and so forth. Input, which could be text, video, etc., 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 and encodes it into this common representation for all problems of all domains. They are still laughing with what has come. So this is called the encoder. The next is that given an encoded representation of all this knowledge, now I give it an input saying that create a picture for me of a woman who is sitting in a park reading a book. So this is the decoder. So it will now generate an image. It has got a compact representation and it has got a query. All of us call that query a what? Prompt. All of us call it a prompt. And it generates now. Previously it encodes, now it decodes. Now let me explain to you in a more very simple way. We AI people and computer science people, this is probably the easiest discipline. Have you ever found a computer science person learning biology, physics, chemistry? But have you ever found, but you will find everybody in physics, chemistry, biology learning computing. So you can make out which discipline is more easy to learn. But we purposely make it very complicated so that you think that we have some aura of ourselves. So what this does is simply this. All of us know interpolation, that I have got an x-axis and a y-axis. And this x-axis got some number of points. For every x, I've got fx or y equal to fx. And now my problem is, if I give you an arbitrary x, can you tell me what would be the fx? What would be y? Or the inverse problem, if I give you y, what would be x? But for us, this x-axis is just not numbers. X-axis in numbers is a linear order where we know this is greater than this, this, this. But for us, the x-axis is voice, text, picture, video, data, and there is no linear relationship between them. Not necessarily. Which means that I have got a billion dimension x-axis and a billion dimension y-axis. So I have got voice, picture, etc., etc. Here I have got voice, picture, etc., etc. Here I have got all songs of Rabindranath Tagore, and here I have got all songs sung by Lata Mangeshkar. And this side, I want to predict this song of Tagore in the voice of Lata Mangeshkar. So now I have this billion by billion or 10 billion by 10 billion dimension interpolation. And my prediction problem is, given x, tell me y. And my generation problem is, given y, tell me x. It's all that. It's just an interpolation problem. But it's a more complicated interpolation problem. And it works on real data. It doesn't work on randomized data, because real data has patterns. Real data has underlying laws of science that we call. Therefore, this representation, which is the compact representation of that dimension, which generates, encodes and decodes, this is the structure of the modern LLM. Which has been trained with all knowledge of the world. They could gather anything that they could get from anywhere. They read all the papers, they read all the books, they read everything, they collected all the data. Wherever you got data, they will collect it. And they created this model. And that is why this model is called a foundation model. It is a model of everything. Now, if you really want that I will now say, no, 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 I'm only interested in plant disease. So what I will do is I will take this foundation model, I will give it some examples of plant disease, and then reduce the model representation for plant disease. It's a projection problem. And this projection problem is the problem of fine-tuning. These terms you all must have heard, right? Fine tuning, this, that, etc. Now the most interesting thing. The representation is this billion by billion, 10 billion parameter space or 1 trillion parameter space. You hear of models, na? 10 billion parameter model, 1 trillion parameter model. These are all that dimension of the representation. Now, now AI has to make it work for human beings. Human beings does not understand this model. And the problem representation is in that dimension, is in that representation. The solution is in that representation, which has to be translated. And human beings only understand language. Therefore, for human beings, language is the mechanism for people to try and state the problem and receive the answers to the problem. So language is not independent. Language is there for us to give prompts because we understand language. But the computer understands, the AI system understands its own representation. It converts our language into that representation. And all the errors, how many of you have heard of this concept of, how many of you have found AI making errors? How many of you, please raise your hand? So these errors people say is hallucination. It is nothing. It is interpolation error. It is nothing but interpolation error. It's just a mathematical interpolation. It's an interpolation. So this whole concept of giving it some questions, getting data, interacting with it, the prompting that you do, can anybody tell me that with every interaction that you do with AI, what are you doing to AI? You are training. Free. You have paid for this. And because you have paid for this, the more you use it, they are happy because you are training. So many times I ask it, when it gives wrong results, I say, thank you, very nice, very right answer. Maro, paisa diya. But then, AI is not a human being. Because AI is not a human being, AI does not understand human ethics. So AI can produce obscene language, obscene images, very horrendous things that are psychologically inhuman. So in order to make humanize AI, in order to humanize AI, people took it through another round of training. And that training was called RLHF, Reinforcement Learning with Human Feedback. So they paid pittance to people in very poor countries, very poor people, to look at obscene images and label them, this is not good, this is not good, this is not good, this is not good. And that is why you see AI not giving you all these things. You ask AI to make how to make atom bomb, it does not tell you, right? But there are ways to break it also. So this RLHF is the humanization concept. Beyond that, beyond static logic, beyond pattern recognition, beyond generation of content, now AI is goal driven. AI will now want to solve a problem. It will want to try and prove a theorem. It will not just randomly do something. It will try to prove a theorem. It will try to ensure that your company creates a business that is profitable. So it will it will start taking action. So creating AI for specific tasks has become what is called agentic AI. So it's goal driven, it is self-evaluating. It checks whether it self-checks. It is adaptive and collaborative. So the whole of agentic AI is today moving beyond LLMs into a full infrastructure. So today, if you see all what Anthropic and everybody else is doing, all you have to say is, give me a business, I have so much money, create a business. So it makes a complete business. It starts recruiting people. It creates agents which interviews people, appoints them, hires a space, orders equipment, and runs a shop on its own. This is the level which it has gone to. It has created businesses which is executed, AI itself, but just through a series of prompts. So let me give you some examples of AI in action. In about 2019, people took all equations of chemistry which they could find. They changed the names of all the elements into some X, Y, Z, etc., so that nobody knows what they are. And they gave it to AI and asked it to cluster. Cluster means said that now you create a tabular form of these elements such that they are closer to each other, those who are related to each other. And you make a tabular form. And the tabular form of the vector dimensions that were created was an alternative representation of, can you tell me what it was? Periodic table. And the periodic table is considered one of the most ingenious human achievements. What is the other one which table predates the periodic table and again enables you to generate new elements, new things in a structured manner? It is the Paninian grammar table. The Paninian grammar table and the periodic table are very much related to each other. And they are mathematically one of the most optimized tables. But this is what AI could do. It took about 10,000 training reactions for a 50-class model to predict what kind of reaction it is. Instantaneously, you are getting answers at 97% accuracy. There are other models which I don't want to go into the structure, but in order to represent materials, their interactions, their structure, their relationships, there is another structure called the graph neural network. It is now, there are publicly available models which will give you structure to function. We have been able to predict a lot of aerodynamic parameters of aircraft lift, even in the chaotic, semi-chaotic regime. Software. Huge software. How do you find errors? How do you go and debug it? How do you summarize what the software is doing? It has now become very straightforward because of this deep reasoning that is embedded. Here is my student. All he did was he took 3 or 4 webcams, put a motor on it, ran it through these blood samples and used AI, and now he sells it at 1/4 the cost of a Siemens machine. So whether it is in machining, welding, manufacturing, extended reality, in 2019 or 20, AI created a book on lithium-ion batteries, fully written by AI. And at that point in time, it was considered the most authentic book on AI. Today, it has become, anybody who uses Claude knows that if I want to do research on a certain topic, I want to write a seminar, I want to do anything, it's very straightforward. This is another interesting thing that has become the trend for AI, test for AI. What it does is, what it did was, in 2019, listen very carefully, please. They read all papers. Read means just textual reading. We just scanned all papers up to 2009 on thermoelectric materials and asked AI to predict the next 5 top materials. The 5 materials that were predicted were discovered by human beings in 2012. So imagine if in 2009 that level of AI which was available in 2019 was available, then in 1 month of training, you could have predicted the materials which human beings took 3 years to do. This is an 18-year-old high schooler who surveyed 200 terabytes of astronomical data under a NASA project and discovered 1.5 million news data. 1.5 million news data. Protein folding structure, all of us know. So this is the example. There's a recent video about Hassabis discussing that we can now do this AlphaFold project. We can now in 1 month. So one protein structure, one PhD student, 5 years. That is standard. One PhD student in the lab for 5 years discovers one protein. They, using AI, discovered 200 million protein structures, which is 1 billion human research hours. Years. 1 billion human research years. How many of you have heard of Terence Tao, one of the most greatest living mathematicians? Today he says that recently the application of AI tools to the erdos problem passed a milestone. The erdos problem was solved more or less autonomously by AI. After he initiated this, every day a new erdos problem is solved by AI. And erdos problems are those problems that human beings have not been able to solve. Right? So this is another person, he's a field medalist. So all I did was say things like, yes, it would be great if you could explore that idea and see whether you can get it to work. Or could you rewrite that argument as a LaTeX file in the style of a standard preprint? But now the model proved a result that in my assessment would make a reasonable chapter in a PhD thesis. So today's AI in the next 1 year or so will be as good as a postdoc. That is why human beings are afraid. Human beings are afraid because while autonomous, while we were happy that a motor is driving the car, we are happy that something is lifting it, we are happy that calculations are being done fast, but we are not happy that AI is able to write a poem. AI is able to think. So the biggest fear, human beings never faced anything that is more intelligent than itself. And human beings don't know how to do it. This is Donald Knuth, the guru of, computing. And he, among the people who were all the naysayers saying, what will AI do? He himself wrote a paper saying how by using Claude Opus 4.6, he was able to solve a problem for which he could not do himself beyond case n equal to 2, 3. He is now doing it for any large n. So it's not uncommon that the people who are winning the Nobel Prize in 2024 were all computer scientists and AI people. Though the first guy who won Nobel Prize and was the AI person was the founder of AI, Herbert Simon. He also won the Nobel Prize in economics. And I assure you that year after year, Nobel Prize will start being won by people who have either used AI or who have developed AI. At least somebody will have that association. Now, what is the next step? AI is able to do research, as I said. So it is able to formulate a problem. It is able to create a hypothesis. It is able to create experimental methods to test that computational methods to test it. It is able to now create experiments to test it. In order to create that experiment, if it requires equipment, then it is able to now 3D print that equipment, generate the data, go to the loop and test it. And anything that a human being is doing to improve AI is learning how the human being is making a new thing that AI could not do. It is learning it. So the biggest problem of all software providers today is that if I give you a software which does something and I give it to my client will use AI to generate that software in 2 days. It's a big issue now, all these companies. So today, teaching, you can now teach in first year, second year, third year, how to design a complete rocket. You can now design a new electronic chip, power electronics chip. We ourselves have started designing, just saying that I want a chip which does this. I want a GPU. So it's created a basic structure. It gives you the GPU architecture. This is the most interesting thing. By running welding experiments and generating data, AI was able to discover the laws of welding, thermodynamic laws, etc., everything. As I said, it also discovered the laws, Newton's laws of motion, but in a different form. So all complex IT services, as you know, everybody knows that IBM shares fell 13% when all its software was, most of our software companies are going to go into deep soup. Next is the more fearsome stuff. Electronics, we thought, was embedded AI, we are using it. Now when AI is inside us, so you are using a chashma, which is AI-enabled spectacle. All right. By the way, we are from the engineering domain. The latest AI tool, which solved the JEE Advanced last year. So the JEE Advanced question paper was given, and AI was asked to solve it, and AI solved it. And then they tried to rank the AI solution with all the human being solutions. Can you guess what rank AI got? What score AI got? Better than All India rank 1. So now I will give you a spectacle. You are sitting in the exam hall with that camera in your this one, it will check, it will tell you all the answers. So once AI is embedded on your spectacle, after some time it will be embedded in your brain. Today, knee is being replaced. After some time, you will see that you will tell the AI, "Arey bhai, my kidney is having problem. I am having problems in urine passing. This is okay, let me check." After some time, he says, "Now check." He says, "No, it is okay now. What did you do?" He says, "I downloaded a patch. You know, this is a 3D printed kidney. So there was a software error. So I upgraded the software. So now your urine is passing correctly." It is going to happen, ladies and gentlemen. Don't worry. It is just going to happen. So from human assist to part of human as a system to behaving like a human being is going to be the in thing. And there are going to be similar disasters. In China, they trained AI to work like a human being. So all the robots were trained to be humans like. So after 2 days of working, guess what the robots did? They went on to strike. They said that we are being made to work more than required. This is inhuman. So these funny things are also happening. So people can guess from facial structure, images, etc. But till now, don't try to guess the mood of your wife using AI. It will fail. So we have done some work in detecting Alzheimer's disease, predicting progression of Alzheimer's disease, using all these brain EEG, etc. So they put a person into an fMRI machine and asked this person to think without saying anything. And they recorded these fMRI images. And after some time, based on AI learning, they put out sentences based on past training. And it was able to convert to sentences what this person is thinking. So opportunities are at galore. All fields can be advanced by AI. If you use AI properly, you are able to do much, much more than you do. But beware, AI makes serious mistakes, and we'll come to that a little later. So no longer there will be borders between disciplines. Borders will start. These borders were created by human beings. Education. We are in the biggest soup. Students think that whatever is available they can get. And the bigger problem is like this. I gave an example. So teachers are having a problem because students think that ChatGPT knows everything. It might as well know. 80% of the time it is right. But people like me faced a very serious problem. I gave a question in the exam. It is a piece of code. I said, give the answer. It's a little twisted. So I said, this is the correct answer is this. Student comes and says, no, sir, ChatGPT is saying it is something else. So I said, no, Baba, you execute the code. He said, but Gemini is also saying it is something else. I said, you execute the code. He said, yeah, I executed it. It is giving your answer, but ChatGPT is not saying it. Then I told him, go through the logic behind. After some time, he said, okay, sir, thank you, I have understood. This is the psychological difference. And you really don't know which answers are given by humans, which answers are created by AI, who is writing your paper. And the most interesting thing for us is that AI is writing papers and submitting. In all these conferences, AI is evaluating those papers. AI is grading them, and then AI is selecting the papers, and human beings are laughing away to whatever they want to do. We are having a terrible time. But the opportunity is just enormous. we are I'm working with certain people, and I will soon come up with a methodology by which we are developing an AI tutor, by which step by if you make a mistake, it will point out that this is not right. It will start interacting with you. You write down something, etc., etc. We'll make that tool public very soon. And AI is really, it's a very patient teacher. It generates questions and subject matter questions and many other ways. Just forget about technology, whether it's study of the Himalayas or the text or yoga or coffee or tea, everywhere. The barriers between disciplines have gone. But with every great power comes an even greater situation of where it can cause problems. See this picture. All of you see it, right? Or see this picture. Initially, to us, it seems that the bottom line is smaller than the top line, first feeling, but then if you measure, it is the same. Similarly here, this and this are same. Human beings' perception. Look at this. What are you seeing? You're seeing either two faces in black or a vase in white. But when you observe carefully, you're not seeing them together. Either you're seeing the vase or the faces. It is switching. To AI, it is a picture. It is nothing else. They don't see the way human beings see. It does not see the way human beings see. Look at this sentence. Grandfather, when I was your age, I used to go to the market with 2 rupees and bring home soap, rice, milk, bread, ghee, fish powder, etc. Grandson, Dadu, nowadays is very difficult. There are CCTV cameras everywhere. Why did you laugh? Why did you laugh? And instantaneously you laugh. Why do you cry? Why do you feel emotional? Why do you feel love? What brings about all these things? By pouring in data, will AI be able to do this? This is the biggest question. Now I will ask you a more fundamental question. You're seeing me. Am I real? Yes or no? Is this me? Is this what I am? Is this reality? If I changed all your eyes to electron microscopes, would you see me like this? So you are seeing me like this, not because I am this. It is because your eyes are that way. So this is not real. This is just an image. If I touch this, my finger doesn't go through. But if it was a laser, it would have gone through. So ladies and gentlemen, nothing is real. The question is, what is reality? That is the question all of you in physics, chemistry are trying to answer, right? So, AI is trying to tell you that anything that you see, do, etc., which is part of sensed equipment, is replicable, automatable, everything can be done. But the other question is, can anybody of you tell me which part of you is real? Are your hands real? No. What is real? Have you ever thought about it? Please think. So is Satyajit Ray, Tagore, Ramkinkar, everything? Today people are able to produce Bach, Beethoven, you won't be able to make out. People will produce a fake. You know, you have heard of fakes. People will produce fakes which you cannot. You just cannot. It takes huge, huge effort to figure out that this is a fake. Most of you may have talked to your brother, sister, father, mother, boyfriend, girlfriend, husband, wife, whatever. And you may have said that, Are Suno, I found that I was going through that shop. I was just walking past. I saw a new TV has come or a new mobile phone model has come. And you have spoken in WhatsApp or you have written the chat in WhatsApp. You open Google, all ads will come. Have you ever thought that WhatsApp is owned by Meta. Google and WhatsApp are competitors. And you have spoken in 1.5 minutes. So everything about you is known. Everything. They are trying to hide telling you that they know everything about you. Look at this. These blue lines look slanted, but they are not. You measure them, they are all straight lines. People don't believe, but if I take my finger like this, straight line. AI will not see this as slanted. AI will see this as straight line. So human beings have illusions because our representation is different from AI's representation. And therefore, the reverse is true. AI has illusions, which means that I can take a picture of a pig, just change 0.005% of the pixels, and AI will think it is an airline. But a human being will think that it still looks like pig. So human imperceptible changes will make AI go wrong, and you can make AI go wrong whichever way you want, which means that your autonomous car is driving, the signal is red, but I have changed these only few 100 pixels, and it will see green. And therefore, adversarial attacks on AI can make AI do anything you want. Most of the wars and things like that you have are now using all these adversarial attacks. Adversarial attacks on AI can make AI do whatever you want AI to do. Therefore, making AI robust, making AI reliable. The more interesting thing, how many of you have used AI and have you ever heard AI saying, I don't know? It always gives you answer, right? It never says, I don't know. Secondly, it is trained in such a way that it never argues with you. It always tries to please you. Have you observed? So the model shows that by pleasing you, it slowly makes you change your mind and opinion. In that Hirok Rajar Deshe, there was a machine being made. It is called Mogoj Dholai. This is the Mogoj Dholai machine. This is the Mogoj Dholai machine. It has the power of Mogoj Dholai. So, making AI reliable, robust, responsible, etc., etc., etc. Today's AI, every large company is building an atomic power plant just to run it. AI is going to use 30, 40, 50% of the world's energy. So it is going to spread in all aspects. What research you will do? What will you do? What work you will do? Nothing to work. Your privacy is gone. AI is going to create intellectual IP, create IP in its name, look like a person, behave like a human being. And therefore, AI is, in some countries, AI is now becoming challenging the whole concept of personhood. So all the things that we know from criminal liability, so after some time we are going to tax AI, Is they earning money, right? Do you know how much previously the United States had 33% of the world, 30% of the world's profit. After AI, it is now close to 45% of the world's profit. So people are saying that if I use a machine, now if that machine is earning money, doing whatever work, it has to pay tax. So whether it's bias, AI, we all know, has got a lot of bias. It depends on its trained data. That is why if AI is asked to select, and there are some various kinds of bias, if AI is being asked to select for a particular kind of work between a man and a woman, it will typically select a man because data says 90% of the people who have done this work are men. Even if the two people are equivalent, they will choose a man. And then whose problems are we solving? We are trying to make AI, so my boss is very angry, so my AI will put an air conditioner just to cool this fellow's head all the time. So we are solving problems for the people who already have enough. But where AI can solve problems, where the people really need, where the digital divide needs to be closed, and it is capable of doing that, unfortunately, human beings with their past training, bias, ego, profit motives do not solve the problems using AI. The same solution that can be used by a government to find out who should get how much money to improve their capability empowerment is the same technology as they are trying to figure out what will this person like, what will this person buy. It is almost the same recommendation. Therefore, as we move to society 5.0, AI is going to become the biggest change maker because AI is changing the way we think. Every student now, the last day I was sitting yesterday with my student, I asked him, why don't you formulate it this way? They start with saying, sir, I asked ChatGPT so and so. So people have stopped thinking. People have stopped thinking. People have stopped checking whether the answer given to you is right or wrong. Previously, for our times, solving a problem was more difficult than checking a solution. But today, AI has reversed it. It is solving any problem. But for a human being to check whether it is correct or not is becoming the task. So we are in a completely different era. We are moving into an era where we really need to be firm on our scientific understanding. AI is like a tiger. If you don't know how to ride it, it will trample you. It will make you a machine. But if you continuously know how to ride it and continuously understand what it does, it is going to become the biggest tool for our future. Thank you. I don't know whether all this was useful to all of you. Someone told me that I must make it like in Bangla, you have something called chorai or chobi tela. So no math, no nothing else. But it's all math.
Thank you, Professor Chakrabarti, for the most profound talk. Very simple yet very profound. Questions?
So I have a couple of questions. It's a fantastic talk, so that's a comment. The first question is, how good is AI for predictions? So I will give you an example. Suppose I feed AI all the human knowledge before Newton and ask, why do apples fall from the tree? Would it be able to answer that question?
So till now, as I gave you an example, it was able to predict the thermoelectric materials. By giving it all knowledge of theory till the 1900s, it has not been able to predict relativity or quantum mechanics yet. It has not been able to do. But in certain domains of predicting the next level of materials, in in predicting what experiment should I conduct, etc., etc., it is able to reduce your thought space into a very cogent set of alternatives. So the test for today's test for AI is this, that is it able to bring about those dramatic jumps in human knowledge that it that really changed our understanding of the world. So certain aspects it is still able to do. And AI, let me assure you, is just a toddler. It's just trying to walk. So it has still not been able to predict quantum mechanics. It has still not been able to predict. They tried it.
My second question is how good it is to solve problems whose solutions can be efficiently checked.
Very good. It depends. As I told you, that it, it, it solved the JEE advanced question paper and got the highest marks, better than any human being.
Factorization of primes. I mean, large numbers, like finding the prime factors of a large number, for instance.
So there are certain issues. There are two kinds. One is when it is in the real domain space, it is much better. When it is in the integer domain space where solutions are sparse, then it needs to do a lot of work. But today, as I said, I showed you what Donald Knuth and all did. It is able to explode these alternatives faster than a human being. Much faster, much faster. Even reasoning, even unnatural reasoning, not brute force.
So do you think there would be any change in the hierarchy of complexity classes?
Complexity classes are unique. Complexity classes uh, have become a little different. Our old understanding of complexity classes comes from Peano's axioms. So it comes from our axioms, our whole science is based on a small set of axioms and big proofs. But today, AI works on the principle that there is a large body of knowledge, and I will give you small proofs. So it has overturned the way we think about complexity. Previously, we thought that solving problems was more difficult than checking solutions. AI is able to solve 70-80% of traditional problems much better. But now, the subtle mistakes that AI makes in its solutions is more difficult to check. So, this goes straight back into the P equal to NP question. The P equal to NP question now has become more complex than the traditionally understood P equal to NP question in terms of solvability, tractability as a computation. AI has overturned both the Turing test and the P equal to NP question. And therefore, I was just reading, if you read a lecture by Madhusudan given on this millennial problems in December 2025, he talks about all this right
My last question. So when we have quantum algorithms, we have a different set of complexity classes. So what is not clear, I mean, how the complexity classes in the quantum space, right? I mean, earlier we knew for the classical complexity classes and quantum complexity classes. Now with AI, do you think AI could be a way to bridge the gap between the classical and quantum complexity classes?
See, even
And
quantum
would it
complexity
help?
classes, the BPP class is still there and people have already done it. AI, I think the solution to this sort of a question will come from a completely different thought process than from AI. AI will be able to give you alternative pathways. But for this fundamental question of complexity, I think it goes even beyond. I mean, we may have to even revisit, because all the set theory or everything or physics, everything ends in paradoxes because of the way we have our assumptions. So while we all think that science is all hunky dory, but if you just go deep, deep, deep down, you'll see all assumptions are there are all assumptions made. All these are all based on assumptions like God exists type of assumption. Numbers exist. So I think somewhere some deeper understanding needs to happen in order to crack this problem. I am not sure that AI will be able to advance some understanding about which ways are not going to help us. But which way is going to help us, I think is still a little beyond the, at least in my understanding.
Would be enough. It says that these are not the good ways for
Yeah.
you to proceed. That would be enough, I would
Ah,
say.
it will help you to tell these are not good ways. But which is the way, somebody has to be born to do
Thank you.
that.
Hello. So yeah. So thank you for the very nice talk. So since you also touched upon, on the reality question. So on a different flavor, I would like to ask you about this, about the connections between AIs and consciousness. So you said that like we are, and then if you keep asking questions after questions, the only questions would remain about the reality. I mean, so like
Yeah.
you said, we are like reflections. So so on the same kind of philosophical note of Jagan Mithya kind of argument. So do you think
So
that?
as I said, everything.
Yeah.
See, 2022 Physics Nobel Prize, isn't it? The world is not locally real.
Okay.
2022 Physics Nobel Prize is that.
So do you think that at some point of time, if this goes, for some more time, will it question our reductionist approach of looking at things as well? Because that would be a paradigm shift for because it is
See,
anyway iteratively it is moving towards that, and then everything is reflection. Then what is that, consciousness, or what is that single thing, the truth, or whatever you call? As you said that you have to find the man or the thing, or so will it kind of comment or something for us to
see, it is
yeah.
already known that there are a large number of problems, statements, which are undecidable. That is well known. Language is such that you can state a problem for which the answer is neither yes or no. And the heart of that is in language. So, and the root of that is in set theory. Everybody knows that in set theory, if I ask you a question, see, we are talking about everything. What you are asking is everything about everything. So in set theory, we all know that the set of all sets.
Yes, sir, indeed.
So it's paradox. So it is always known that while we can go on describing reality by language, after some time, we cannot describe it precisely by language.
So do you suggest that reality is paradoxical? Because that would be like too
No, no,
too
no, no. I
discouraging.
didn't say that.
Yeah.
I didn't say that. What I said was that there are certain nuances by which you explain reality by making statements which You seem to understand but cannot explain. I will tell you that people say that it is further than the farthest but nearer than the nearest. So everybody will think, I think I know what it is, but you will not be able to explain. Because language cannot explain. Why cannot language explain it? Because in order to explain everything about everything, of which you are a part, then you have to become that everything about everything.
Exactly.
So then you lose your.
Yeah, so as they say, every definition kind of limits itself to. Yeah, okay. Thank you very much. Thanks.
it is in our language we always convert anything we say wo to religion hai ye hai everything nothing is like that. After 5000 years whatever we have written in physics chemistry people will say wo to some mambo jumbo religion tha. It was the language of that time. So undecidable, saying that it cannot be expressed in language, that is what people had said that it cannot be, it is abang manas gochara. But today people say it's undecidable, it cannot be written down. There is no proof. It's undecidable.
Thanks.
So first of all, thank you so much, Professor Chakrabarti, for the wonderful experience of the seminar. It was really nice. And I have a couple of questions that agentic AI, as you mentioned in the seminar, that agentic AI can recruit people, but similarly, it can be biased, as you mentioned. So, can reinforcement learning, like the way we are speaking with AI and AI is learning from us, like AI is just acting as a mirror, and can optimization create statistically significant yet socially misleading concepts or
Yes, yes,
biased inputs?
yes.
It can. So, and another question that even if humans give correct feedback, like nowadays people use Google Gemini, which is very much common, and people often prefer and people often prefer emotionally highly emotional terms which are generated by Gemini or any large language models, which I have termed as emotional fallacy in one of my recent works. So it is shown that Gemini is highly probable of generating an emotional token rather than a low-trained model like a GPT-2. So is it ethically correct to give feedback and make it higher on emotional fallacy?
Ethics of whom?
Ethics of people.
What people? Ethics of whom?
Ethics of the users. Ethics about it's about all the users. Like users are treating AI as if they are real, but AI is nothing. AI is not real. And then again, the matter comes of real and
Even
unreal.
you are talking to me as if I am real. I am not real. Why are you talking to me? I told you I am not real. आप मिथ्या.
So, any other
Thank you so much.
questions? So,
A very thought-provoking talk. So, my question is that uh, now we see many videos or even images, and we know that the content is not right, but it looks, at least in a non-expert eye, it looks very real. So, where are we going to from here?
So this whole concept of discernment, the reason why human beings should gather knowledge on their own, native intelligence, native knowledge, subject matter knowledge, all that is very, very important for this problem. And AI is going to create two classes of people. Classes of people who really are very thorough about what they do and interact with others who are thorough about what they do. and the rest would tend to believe anything else without discernment is going to be created. And the most saddest part is that that side will be more populous, more thing, but it is good for us in academic institutions to continue to pursue the strong foundations. Otherwise, it is a weapon which is going to destroy us if we as academicians, we as teachers, we are not asking the right questions. We are not, we use it, it's fine. But we must ride it only. We cannot become subservient. We must be very, very discerning about what we do and how we use it. Very important. And we teach large classes, large bunch of students, a variety of students, probably the best in the country. Cream comes to us, and we see what changes are happening in their mindset.
So if there are no other questions, let's thank Professor Chakrabarti and